Great. Since most of the data, since most of the data as of today lies in the existing databases, there always was a need of moving the data back and forth between HDFS and HDFS and existing relational databases. So keeping that in mind, as well as keeping in mind that data is going to be big, Sqoop was designed. So Sqoop is essentially an open source tool that extracts data from structured data sources, okay, structured data stores such as any database or any, basically a database, okay, or anything that implements JDBC. All right, and it imports the data into Hadoop for further processing, and after processing it puts it back into, it can put the data back into an RDBMS. Okay, so also you can move the data back and forth between HBase and any database, and you can export the data from any databases. Okay, in case your database is not supported, it comes up with a extension framework, okay, by the way of connectors. So you can customize its behavior, or you can write your own connector using the extension framework. Most likely your database is going to provide JDBC connectivity, and that is good enough for Sqoop. You don't have to write anything else. Okay, so if your database supports JDBC, you are already there. Okay, now, okay, so basically Sqoop is a way for in and out data into the HDFS, Hive, or HBase, okay, from your relational database or to your relational database. Okay, now we have, so let's just for this will, okay, so this is not something related to, cool. Now here we have, we'll say Sqoop. Let's see. So Sqoop client is installed on all machines, and if you say Sqoop help, so the font is the font big enough now? All right. So is the font visible enough? Good, good. So basically, Sqoop provides a way of, you know, importing, exporting the database, and import. Import means import a table from database to HDFS. Okay. All right. So you can actually SSH to Hadoop 1, Hadoop 2, Hadoop 3. It will work from all the places. Okay. And since Sqoop doesn't have any server, Sqoop is basically a client library. Okay, so it doesn't matter from which server you, whether you're running it from data node or you're running from anywhere, it will find the Hadoop installation, okay, locally, or you can actually define Hadoop installation, and then it automatically will figure out which one is name node, and then it will work. Okay, and for seeing like what does it mean by Hadoop import, Sqoop import, it will tell you all the details, like what all things you can customize. All right, so let's take a quick example. Let's take a quick example, and so feel free to ask and stop. I mean, I will be moving a little faster, so unless and until you ask a question, I will not be stopping to answer, stopping to wait for your question. Okay, so But that does not mean they do not ask the question. Okay, please feel free to ask the question. All right. So Sqoop connector is basically a modular component that uses extension framework. Okay, just like any extension framework of Eclipse, it also comes up with its own extension framework, and you can customize it, but you don't have to generally worry about it. Most of the available connectors are MySQL, Postgres, Oracle, SQL. So if you look at it closely, everything is already covered. Okay, even the third party, little less common ones like Teradata and Netaja are already covered. Okay, so you can fairly assume that SQL Sqoop connectors you won't have to extend by yourself. Now let's have a quick run, and so let me check if my database is running. Good, it's running already. Good. Now I don't have to run it again. So did it support ODBC? I think it should support ODBC because you can make a connection to any database which supports ODBC via Java. Okay. And all right. So anyway, I'll make a note of it and we'll publish it. I'll find it if it supports ODBC once, and I'll publish it on the forum. Okay. Let me just make a note of it. All right. Now, did it support ODBC? Okay. Now, moving ahead. So what we are trying to do is first, let's create a sample database, sample data for you. All right. So what we are trying to do here is we will create some tables and some database in our MySQL. MySQL is already running on this server. We will create a table onto this server, and then so let's create, we logged into MySQL. All right. The password for MySQL is nothing. Okay, but don't fiddle with it too much. Okay, Sqoop example, let's say we call it. So, all right. All right. We'll call it Sqoop ex8. Use Sqoop ex8. Cool. Now, next thing we are going to do is we are going to grant all the privileges on on this. All right. Yes, you can use the MySQL on your local machine. It is just that wherever you are running Sqoop, okay, it should be able to connect to your database as well as it should be able to connect to our HDFS, right? So to make our HDFS available to the Sqoop, you will have to install Hadoop on that machine where you are running Sqoop. Installing Hadoop does not mean you're going to install the server. Installing Hadoop means you are going to install the client, Hadoop client, in which you will mention what is the name node and other things in the config, as well as you will establish the trust between the two nodes, between our servers and your local server. Okay, so it is going to be a little longer process than you would have expected. So it would be easier as of today to use the existing servers itself. All right. So was I able to convey, Cletus? Okay. All right. Now, all right. So we have everything in place. Now let's create a table. Create table widget, and there we go. We have created our table. We say star, select star from widgets, and we say describe widgets. We are in MySQL for time being. Okay, so good. We have all the columns. We have got these columns in place. Now we are adding some values to widgets. All right, let's see what is there in widgets. Good, good. So we have got a widgets table, and all we want as of today is to copy this data onto our HDFS. Okay, okay. So, all right. Yeah. So what do you mean by when you say Sqoop app? So this is basically name of the namespace. Okay, we just created a database called Sqoop EX8. It's basically the name of the database which we are creating, or you can think of it as namespace in which a bucket or a bag and in which we will be putting all our tables. All right. So you can create your own database for this example so that you do not interfere with other people's work. Right? And here we are giving the basically here we are giving the privileges to dot star as in the regular expression, which means all the databases whose name starts with Sqoop EX. All right, that's what we are trying to do. Cool. Now next, moving on. So we created the database, and now we are in a position to import the data. So next thing is I'll leave the MySQL as is intact. My all right, and all right. I think it will be better to quit it. Okay, now, and those of you who do not know, we call it. Okay, I'll keep that demo separate. Okay, because if there is a way to manage your windows and sessions inside Unix, so that you so that even if you exit you can switch between the windows, right? I'll show that some other time. Okay, specifically that will be a good approach when you are having separate accounts. We'll have your separate account soon. And okay, now moving to HDFS. Okay, moving to HDFS. First of all, what we are trying to do is we are connecting here. Let me just copy it to the text editor. We are basically importing our whole table into the database. Okay, our whole table into the database. Oh, sorry, what I'm talking about. So here, what we are talking about is for this database, this table we are importing into HDFS. Okay, let's just see what happens. So you can see that it's basically running that also into a MapReduce job. Why? It created multiple MapReduce job which all will be connecting to the RDBMS and importing the data parallelly. Okay. So here probably the other server, Hadoop 2 or Hadoop 3, could not connect over MySQL, and that is why it was not able to connect. Okay, you see, never worry, it will try 2-3 times and then it will work. So it says all of them have failed, and so basically whenever, let me change it a bit. Hadoop1.nobigdata.com. Let me see what happens now. Telnet Hadoop1.nobigdata.com and 3306. 3306 is the port. 3306 is the port on which our I'm just trying to check if other data nodes are able to access my SQL. Hadoop 2 is not allowed to connect to this MySQL, and therefore it has been closed. Oh, this is the reason. So basically, okay. So let me just say Hadoop 8, Hadoop 8. Alright, let's see if that works. Okay, now let me see. Now this guy is able to connect. Alright. So Hadoop 2 is now able to connect happily. Now let's run our example again with Hadoop 1 nobigdata.com Sqoop ex this, and let's see what happens. Is it giving the error still? No column generated for the, okay, so it says access denied for the user blank. Okay, most likely I would be making a mistake with respect to the Sqoop ex. That is right. Sqoop ex8. Sqoop ex8. Okay. Okay. MySQL. Okay. MySQL. Let me Okay. MySQL minus user root and minus host hadoop1 dot no big data dot com. What? Okay, basically some permissioning issues. Okay, that's a separate issue, I think. So I'm trying my luck. I'm trying to see if basically if the task tracker of the local machine is what is being picked up, then it will work. If the task tracker, if the task node or the date checkout spaces. Okay, so now it gave a different error. It says that the output here is already existing. Okay, so let's just remove this file. It says, okay, this already exists, right? Now, if we have Hadoop fs minus rm, all right. Now let's try again. Let's see if we are lucky enough to. Okay, okay, good, good. Now if you see the URL to track the job is Hadoop 1, which means we happen to get a slot. Basically, our work is being done by Hadoop 1, and our MySQL is also executed on Hadoop 1 itself. Therefore, we have already established the trust login and password between Hadoop 1 and localhost. Therefore, they are able to fairly connect. But in case the work is delegated to any other database, then it will become difficult. I'm just hoping that it works, because in 99% chances it won't work. Okay. Basically, we'll have to set up our MySQL such that we let's see if I'm just playing a gamble here. Okay. Anyway, it's not working. We'll have to look at some other problem. The driver has not received any exception. Communication link failure. Okay. Okay. Basically, it's not able to connect to our database. Let me just see what all need to be done. Okay. Okay. So Naveen was asking something. Can you explain again why this is okay? Right. So there is no reduce involved in this process. It's only the map part. Okay. In this map part, basically, it's running on multiple nodes and getting the data from the database and copying it here. And again, it's not able to connect. Okay. Okay. So is the presentation not available on the portal? Or it's not? Yeah, we have MySQL on Hadoop one. All right. And so let me just give you the presentation for time being, and then you can. So for time being, I'm just copy pasting the link here in this window, and then we can go forward. Right. All right. So Naveen, is your question answered? We have MySQL and Hadoop one running. Yes, Sini. All right. Great. So basically, right now I'm not able to give you a demo, and I mean yet to figure out why. So when I'm saying JDBC MySQL and the table is connect, I'm basically talking about this. So Naveen's question is, yes, basically I'm wondering how does a map work on a database? Basically, in case of a map will be what exactly the map would be doing is in the map code, what exactly will it be doing is it will be reading, it will not be generating essentially you know the usual way. It will be opening a JDBC connection to the database and reading the data from there and putting it into the file. Okay, I'm putting it into the file. That's all. It will be using a different kind of input split. It will be using a different kind of input split. Right. So it will be having its own input split in which the way we had splitted the file, it will split the rows and give it to each individual nodes, where each individual nodes will just dump it to HDFS file. Okay, so here more than MapReduce logic, it is that input split which will be doing its magic. Okay, have a look at the Sqoop's code. You will quickly figure out that it's not, I mean, though it's a big deal, there are too many things, but with respect to distributed nature, it is basically creating a RDBMS kind of input split. All right. Now, okay, so ideally we generally have we may have made some mistake while defining our database. So I'm trying to use the older one which used to work, but I do not think that it will work. Okay, so it's not able to do much. Okay, so this one has worked. This one has worked. Out of 3 map tasks, 2 map tasks have failed, and the work basically got done at Hadoop 1 instead of other ones. Okay, you can see that on the server. All right, now as you can see now that this is where it has imported the data. So whatever we had on those tables, it is imported here. Okay, and as a comma separated file. All right, and as well as we have got a class called widgets.java which can be used as a data model in case you have to keep doing it again and again. And you can use the widgets.java. It contains all the code to read and write. Okay, so it can basically work as a data model for you. All right, so basically the problems I was facing was with respect to the permissioning of my SQL database. So I used an older database which I had created earlier called Sqoop 2, and then imported that table. And this table which I showed you is under a folder called widgets in a file called part something. Okay, so here you can see, right? So we have part just like any other MapReduce code. In this we have got Hadoop fs minus cat this. All right, so it's a comma separated file. Now Now the next step, if you have to again import this file into Hive, you will have to create a table, and the definition can also be imported from MySQL. Okay, the definition of the table can also be imported from MySQL. Therefore, we'll have to run another, we call it, so first we created HDFS file in the first go. Now we are creating, a, using again Sqoop, we are creating a table in the Hive. Instead of we trying to guess, instead of we trying to create each column by ourselves, we are using Sqoop, which will query our database, query our table in MySQL, and then create that table in Hive. That is what this command is trying to do. Okay. Now, next step, if you are in my place, so what will you do is, okay. So here, what you're going to do is, so we created a Hive table. Okay. We created a Hive table. What's the name of the table? Widgets. And let's see what happens to widgets. Create Hive table, connect, and then show tables. So it by default, whatever is the default database, it creates the table in that. And here you can see there is a widgets table in Hive. And we say, what was the command? Can anybody help me? What was that command? Formatted. Okay. Describe formatted, which tells you exactly what kind of table it is. It says that it's a managed table. What does it mean by managed table? In case you drop the data, of your table, of this table, the folder will get deleted. Okay, and the data of this table is going to be located at this place. And right now, let's see, select star from widgets. Again we are inside Hive, and this is what we have right now. Okay, delete, this is probably from previous one. Okay, let's just, we want me to drop table widgets. Let's just drop the table. Okay, let's just try to create the table again. Good. Now I'm going into Hive. It should have the widgets table created again, and see what is there in the table. And also describe formatted, and we call it describe formatted. Alright, so there is a table called this, and let's see what is there. Select star from widgets. No, it's not there. And also again, let's check. Good. So we have, first, in the first set, what we did was we copied the data from MySQL to a comma separated file in HDFS. Now the next step is, and also note that while while our Sqoop created this table, so first we copied the data from MySQL as a comma separate file in HDFS. Second, we created a blank table with the same set of columns as it was there in MySQL. And also note that by creating this Hive table, it has put the same same parameters of like comma separated values, as well as field delimiter is comma, and line delimiter is new line. Okay, for this table. Now, when we are importing our comma separated file, which was imported by Sqoop in the first previous command, it is going to be easily imported. Okay, why I'm saying this? Because while creating our any Hive table, we need to specify that when we are importing data into this table, what format the data is going to be. Okay, now the next step is to basically load the data in the path widgets into a table called widgets. Okay, let's go into Hive. All right, now it is imported. Let's see what happens. So the data has been imported. All right, so there were two steps. First was import the data to HDFS file. Second, create an empty table based on our MySQL table. And third was to load the data in the file from HDFS into this table. All right. Now, instead of these three steps, you could also simply import directly into Hive using this. We could say SQL import connect to this data as well as do the Hive import. Okay. So all of this will happen in a single shot. Sounds good? So if we, let's say we, not this, we go to this and we call it so. Alright, so for this we'll have to drop our table and then work on it. Alright, okay. So it's saying now in a single step we did all the things in a single shot. Alright, now let's keep trying multiple times, and we know the reason why it is so, so nothing to worry. Good. So it has finally, it cried a lot, but it imported the data. We can see that. Select star from widgets. Good. So it did all of this in a single shot. All right. Now, similarly, so here we were successfully able to import data into Hive. On the similar line, you can import your data into HBase. Okay. In HBase, what we are trying to do is we are basically, let me see, we have so what we are trying to do is we are trying to import this MySQL table into an HBase table called myHBase table and into a column family CF1. Okay, let it try a bit. Let's see what's going on with our HBase is running fine, HDFS is running fine. HDFS is just giving one error which we know that our secondary name node is down. Oozie is not running. So Oozie will have to start for the later session. Alright, why it is giving so many errors? Alright, so we can test what's going on from here also. So this time the problem with it is cannot access HBase table. Okay, so it has launched 3 maps and no reduce as of now. Can Sqoop import from object database as well? Also, in case of RDMS, how does it deal with reference tables? So in a very simple words, it doesn't deal with reference tables. Okay. It tries to consider the table as the independent entity without any referential integrity. Okay, and regarding object database, I'm not sure if they are connectors, so I'll just make a note of it. As far as I knew, does it support object databases such as MongoDB? So that I need to check. Alright. So how many errors? Launched 8, failed 8, which means 2 were successful. Okay. Okay, which means at least 2 were successful. So let's say I say AdSpace shell. Oh, we call scan. Why can't I get it right in a single shot? Hmm. So it has imported the data which we were trying to import. All 3 records have been imported here into a column family CF1. Remember, we always create a column family for the database, and here while importing our table from MySQL, what we have said is import this table from our MySQL database, this one, into an HBase table, this one, into a column family CF1, and this is where our table is. Okay, so you can see row number 1, column family C1. At this time, the value is this one, and the column name is design comment, design date, and price. Okay, and then there is something called version, visit name, and all these things. Okay, so this is basically a single row, this is another row, and this is another row. All right, so we were able to successfully import the data into our HBase. And if we have to do a similar thing, if you want to import the data from Hive to MySQL, again you can do the same thing. So say you have got a file. Okay, all right, now what we're trying to do is we want to show you how to export the data from Hive to MySQL. For that, first we need to create one HDFS file, and then load this data into Hive table, this one. And so create a file called sales.log, create a table representing this file in Hive, and then load this data into our Hive table. Once you are done with loading the data into a Hive table, you can basically create a MySQL table, a parallel MySQL table, and afterwards you can export. Okay, afterwards you can export. Now, so here we have Hive. Okay, so let's check if we have already created a table called sales. Cool. So sales is already there, so we don't have to create the sales table. And we want to import this into our MySQL database. And we say show databases. And we say use Sqoop ex2 and show tables. We have widgets table, but not so show tables. Sales is there in the test. Select star from sales. Right now, sales table doesn't have any record. Therefore, we can easily import the table into. Alright. So launched map transfer. Okay. So I think nothing has been imported. Alright, so it seems to work this time. Fingers crossed. It's basically the problem is that we have not allowed other task trackers to access our MySQL, and that is where the problem arises. When the work is distributed amongst these various nodes, they try to connect to our MySQL, and if they fail to connect to MySQL, they start giving error. And if you are lucky and our task tracker is local on the same machine, then we are able to make it work. All right. All we need to do in this case is we need to just give the permission while creating the database. While creating the database, we just need to give the permission properly here. We have given only the permission to the local host. We need to give the permission to others as well. So I need to actually see how exactly does it work. We need to understand in MySQL how can I give these permissions, or how do I establish the login password kind of uh, way between our Sqoop as well as the between Sqoop and MySQL. Okay, so I'll have to see how can I call Sqoop with MySQL user ID and password. Okay, so it's stuck somewhere. And, all right, so I'll finish. Don't worry. All right. So that is how the Hive works. Hive basically helps you doing the data import export between RDBMS and our RDBMS and HDFS, HBase, Hive. Sounds good? Where is it stuck? Okay. So moving on. Export command basically says that we are trying to, you can see that. So we are saying export connect to MySQL database. Table name is this, and here we are saying have only one mapper. Right? I think yeah. And this is the directory in which our Hive table is stored. Okay. This is the table directory in which our Hive table is stored, and we are saying import. Okay. This is the directory in which my Hive tables are stored, and input fields are terminated by comma. All right. Why does it take so much of time? And also note that for every work we are doing, it basically is creating a jar containing maps and reduces for this purpose. All right, never worry. So moving on. So this is how a Hive to MySQL, MySQL to Hive, or and in similar example, we can also do the HBase to MySQL and HBase to MySQL and HDFS to MySQL in the same way. Okay, this is essentially, if you look at it closely, it's essentially HDFS to MySQL, because here all we are trying to say is this is the directory which contains my file, and this file is essentially a comma separated file, comma separated, new line separated, and that's all right. So as an exercise, you guys should try to run these examples by creating proper database, Try those who are acquainted with MySQL, they can create their database so that it can be accessed by other systems. Okay. And how do you check if you can? You log in into Hadoop 2. You log in into Hadoop 2, and once you have been able to successfully log in into Hadoop 2, you do MySQL and provide the host name of Hadoop 1 and try to use your database. If you are able to use that database from Hadoop 2, that means you have created your MySQL databases such that they can be accessed by all task trackers across the nodes. All right. So let's go back and see the status of our services. Services are okay except for Oozie, which is not running. We'll have to turn it on.